So, welcome to another exciting Java class. We have a homework that's due today, and I was wondering if anyone had any troubles with it. Brian, how'd you make out?
Didn't finish.
Didn't finish?
Didn't finish.
Was there an issue?
Yeah, I couldn't get my Java classes to run in my terminal to start a server.
Well, now let's see.
Because your book followed a DOS box.
Yeah, you don't need that. We didn't use it in class.
Yeah, but I have a terminal. So, for example, the command start.
What do you mean you have a terminal?
By terminal, I mean Linux-based command line.
Well, I gather you don't need that, right?
But perhaps I will. That was the route I took, and that's why I didn't finish.
Yeah, I think some people got a little bit distracted by trying to follow the details of the book without using the guidance that we had inside the course. Turns out, if you're using the RMI registry inside of the code, and you're using the singleton pattern, then what you can do is you can look up classes, and then you should be able to get a reference which will allow you to invoke them remotely without your having to start a registry externally from IntelliJ. If you do start a registry externally from IntelliJ, then you become mired in issues of class path, because the RMI registry will no longer be able to find the stubs and the skeletons for the RMI code in your path unless you launch it from the right place. So then the other question is, well, what happens if you make a change? So, for example, suppose, and I had this with Kyle the other day. He came in and he said, "I'm making changes, but they're not showing up in the RMI invocations," he says. And I said, well, you've got to restart your registry every time you decide you want to rebind a class to the registry, because if it's already bound, it's not going to reload the classes in the virtual machine. Here's why. The Java virtual machine requires that you do dynamic class loading. Dynamic class loading requires that you have a fully qualified class name with a package. Once the class loader tries to get a class for that name, it's done, and it takes that bytecode and puts it into its memory, and it becomes part of the namespace for the virtual machine. So whenever you go back to the class loader, this is the default class loader in the virtual machine, then if you said, well, give me that class, even if the class has changed and been recompiled and generated new bytecodes, it'll say, I got it already. It's cached, and it won't show you the fresh version. Because of that cached version of the class, you must restart the registry every single time you make a change. Now, that's because you need to change the context for the loader. So loader context is one of those things that you could have changed if you started a class with a different name each time, or if you started with a different class loader each time. But that's a pain. So the way I do it is I restart the registry all the time, and I make sure the registry has the correct class path, because I start the registry within IntelliJ. That way the registry inherits the class path of IntelliJ, and if you made some changes to your implementation, it will be found, even if you don't change the class name, once you restart the registry. So you've got to recompile the implementation, then you've got to restart the registry, and have the new implementation rebound to the registry, or else things just won't work. You'll be using an out-of-date bytecode instance, and that's critical. And it'll just be one of those it didn't work things. And so you kind of have to be careful about that. So I mean, if you want to go the other route, if you want to start RMI registries from the prompt. Okay. Then what you do in, I don't know, I'll do this in Windows because that's what I have, but I could do it on your system if you're running TeamViewer. I could get in remotely and show you how to do it. You can start the RMI registry this way, RMI registry. Okay. Doing that where I am right now will do you no good at all, because the RMI registry by default is using the present directory as its class path because it's in the wrong attach point. What you need to be, if you're going to do this from the command line, you can either specify the RMI registry class path, or you can change your directory into the location for your compilations, probably out, production, project name. Now that is a directory where the output from the compiler will put all of the byte codes. Now if I run the RMI registry, it'll listen on the default port 1099 and have the correct class path, especially if you spell it properly. Whoops. Okay, I'm spazzing out now. RMI registry. Oh crap, what happened? It's my trackpad. Registry. I wish I could disable the trackpad. And so now I can guarantee you that I'll have the correct class path, but I have to stop and restart the registry every time I recompile the implementation anyway, because the RMI registry will load up a class after binding and then be done. Now I can locate this registry without starting it. In fact, if you go to if you're in the singleton RMI registry pattern, right, where we're parametric singleton registry, right? What's he doing here? He's doing get registry and then list names. So if I try to start a registry, let's see if there's a main in here. I can start it at different ports, or I can locate the registry. So let's do that. We'll start the registry on port 1099, or locate the existing registry, and now it'll tell me if the registry is there. So locate registry says get registry. This is part of, let me just make sure I got this right, the Sun RMI registry package. So locate registry is a class that Sun provides to you, and it will let you locate the existing registry on your system. So it'll use by default the local host, but you can spec the IP address. It'll use by default port 1099, but you can spec that as well. And presumably if I go to locate the registry, nothing happens. Now this is one of those you got to be patient things. Yeah, so that works. So now let's assume that your registry is not running. Okay. And we try and locate the registry. What does he have to say for himself? Looks like he got something. He got an IP address and port 1099, so there must be a registry running somehow. Locate registry, get registry. Does this actually start a registry for me? I have to check the locate registry, get registry Java doc. Get registry returns a reference to the remote registry for the local host on the specified port. So he must have to create one, right? This one says create registry. So does this make a registry if it isn't already running? It doesn't say. It returns a reference to the remote object registry.
It says it throws an exception if it could not be created, so it must create it.
Yeah, it must create it. I have to assume it created it if it didn't already exist. Get registry. Get registry. Here the registry is set to null. Then what does he do? Live reference object registry ID. He looks for TCP IP endpoint, creates a proxy. Looks like he makes an instance of a RMI registry here, near as I can figure. So locate registry will make an instance of an RMI registry if it doesn't already exist. And if it does exist, the reference should be the same. So if I run this program twice, I should get the same answer. Let's see if that isn't true. Yes. It's exactly right. Now the question becomes, how would you get the path for the RMI registry? I'm not sure that the registry path is something you can gain access to. I can list the names, but I cannot know the path. All right, there's no provision within the registry in order to return the path. Only a list of names. So in a way, the registry is little more than a name lookup server. It's returning locations or references to instances of objects that have been bound to it. Yes, sir?
It says the RMI registry can pass an argument to the Java interpreter as one of its command line options.
RMI registry can be both a command and it can be an instance of a class. So when I run RMI registry on the command line, there's probably a whole bunch of options that I could gain access to. Like, for example, if I type in help,
yeah, there's just that.
I can get the options. Now, what are the RMI registry options?
Just negative minus J.
There have to be other options, right? I have to be able to set the class path.
Minus J. With any Java option. Used in conjunction with any Java option.
So then the Java options, they let you change the class path.
Yeah.
So in theory, RMI registry minus CP dot $10.99, enter. He says options include minus J runtime flags. So then that has to be minus J.
You have to include both in conjunction.
I don't remember how to do this. I think it's class path equals. Alright, so it's Java minus help for me to find out what the options are. And there should be a way to set up the class path. Yeah, it's minus CP, and then there's no space. Oh, there's a space between CP and, I thought it was an equals, but that's not it. There's a space. So I wrote equals. I should have written space. Is it possible you need the space in here? No, he says he doesn't want the space. So that maybe someone has an example of...
Class path is searching for a path of directories where CP is the same thing.
It's the same thing.
Never mind.
So I should be able to set an RMI registry command line path, and maybe this will show me how, as I don't remember. See, was it really important for you to start this from in the command line? Because I'm not...
I mean, like I said, I just followed the directions in the book and got stuck and didn't have the time to seek alternative methods.
Or ask for help.
I did.
Yeah, I asked you if you were following the directions in the class, and you said you were following step 6, and I said, where's step 6? And you said it was in the book. And I said, yeah, but we're not using the command line interpreter in the book. We're running it straight out of IntelliJ. When I wrote the book, I don't think I was using IntelliJ. I was using like MetroWorks Code Warrior.
Oh, I get confused because in the last line of the assignment, you said use example book, and I calculated the same. But I didn't know that in using IntelliJ, I can figure it out.
Yeah, I mean, I think what you wrote, and I must have saw this at 3 in the morning, is, oh, professor, I don't know how to do the homework.
Oh, I did.
And I just said, well, maybe we need, like, a conversation, right? And I didn't feel like I should call you at 3 in the morning because some people find that offensive, especially if they work during the day. So, what happens here, and this is like, an important part of what I would call the distance learning milieu, right? This is the environment when you're trying to do these courses after I record them like this, is, watch them when you still have a few days to do the homework and give yourself some time. I know you can do it asynchronously. I know you can watch it anytime you want, including the day before the homework's due. But, dude, if you could watch it like on Saturday and then, reach out to me on Sunday, I could come in remotely and help you out. But if I get an email at 3 in the morning, my options are limited. I think I just responded by saying, well, would you like me to give you a call? And I don't think you answered me at 3 in the morning because you were sleeping. I mean, I could almost see coming, if only I could have gotten into your dreams and given you the answer. Then you could have woken up smarter or something. But what can I do with no time? And of course, what can you do with no time? So this is very much you got to manage your time better when it comes to doing something where you think you might get stuck. Let me say that it is very educational to be stuck, because then when you are shown the solution, the lesson sticks because you were frustrated from being stuck. So there's nothing wrong with being stuck. That's learning. That's important. I get stuck. I need help. And when I get myself unstuck, I really remember it much better than if the answer just came easily. So there's, it's totally okay to be stuck. And it could have been, something as simple as don't use the command line, use IntelliJ. Or, ignore the book where it says step 6. And I think I mentioned that in my email. I said, look, don't use that. Use what we did in class.
Yeah, because I did the same thing on Monday. I thought I was stuck with it.
Yeah, and you said I'm stuck on step 6, and then what did I do? I responded with the homework assignment, and I said, "Where's step 6?" Right? I mean, what step 6? And you're saying, "Oh, it's step 6 out of page 458 in the Java for Programmers book." Like, and so then I said, "Well, I'm not a mind reader. I didn't know, so don't use that." Yeah.
It just bugged me because I found a demonstration online that was accomplishing the same thing, and they gave instructions for the Mac terminal, and I still couldn't get my class.
I was looking at other ways to do it, and none were really working.
Well, if you're going to use, JDK 1.2, you can start using the RMIC compiler. I think RMIC, yeah, he's in my class path, right? So now I can use RMIC and generate stubs with byte codes as old as version 1.0 or 1.1. And if I do that, I'm really trying to get something that will be compatible with old age Java code. But if I feel like my compiler is more modern than JDK 1.5, which means, I don't know, a compiler that was produced at some time after 2008, then within the last 8 years, right, a reasonably recent compiler, then I'm good. So let me just sort of historically, JDK 1.0 came out in 1994. By 95 we had 1.1, and by 96 we had 1.2. So if you really want to make Java code that's compatible with JDK 1996, okay, you can do that. But why would you want to? You don't need to, not for this homework, right?
Yeah, so in your book you had little directions with using MIC, I believe?
Yeah, RMIC will allow you to create the stubs and skeletons, but that's now dynamically created. I had a nice lecture about proxies, and I tried to explain about how these were, instead of semi-automatic static proxies, they were dynamic proxies automatically generated by the internals. There's another way to generate RMIC. If you want to do that within IntelliJ, you go into the RMIC compiler settings, and then you can enable RMIC stub generation. And you can even generate the Internet Inter-Orb Protocol stubs for Corba invocations so that you can invoke Fortran on legacy computers and write your code in Java. Yes, sir.
Could it have hurt my progress to use the command line to run the RMI registry and start my server class? Could it have hurt, or could it have only helped?
If you decided to do everything through the command line, you would have learned something about using the command line and the old age tools. And so, one of the dangers, I think, of doing that is if you take the hard way instead of the easy way, it will hurt your progress because it will require that you take more time to work through it. So the first time through an RMI example, I would like to encourage you to use the easy way. Now, compare it. Here's my example, right? Suppose I said to you, well, I'm going to teach you calculus, and we're going to start to learn how to take a derivative by learning the fundamental theorem of the calculus, and we're going to learn how to do it with limits. Right? Then after you find out that all you need to do is take the exponent, multiply by the exponent, and take the exponent down by 1, you say, I'm so pissed off. Why did I need the fundamental theorem of the calculus? Then they did the same thing again to you in ordinary differential equations when they told you how to find the homogeneous solution, and they made you solve for the exponential. And then they said all you need to do is turn it into an algebraic expression and solve for the roots of the equation, and then you'll have the homogeneous solutions. And then you get all pissed off and you say, well, why didn't you just tell me that to begin with? So what I'm doing is I'm giving you the nice way to do it and to make it easy at first, and then if you want to do it the hard way later, you still can. So if you want to go back and do it, your derivatives using the fundamental theorem of the calculus, you can do that. Yes, sir.
I just had figured it out.
And you figured it out.
Yeah.
So what was the answer?
So I started my RMI registry above in the parent folder of the class path folder.
Yes.
Called my RMI. And then in my other terminal window, I ran, instead of inside of the folder my RMI, again in the parent folder, and running my RMI hello server, for example, and it started.
So it was the location of the RMI registry that did it.
No, it was the location of where I was trying to start the RMI hello server. I had to be in the parent class and run my RMI hello server.
Okay.
And that may
It sounds like the path would have changed if you were in that directory. Right? Because if you're in the directory where the class files are being generated, then it's going to be able to find those classes.
Yeah, but it couldn't. By being in the class and just saying Java RMI hello server, it could not run the class. It had to be in the parent folder, where the registry was also running.
Is that because the classes were packaged?
They were not packaged. Yes,
Were
they
they
were
in
a single.
They were in a package. Well, if they're in a package for the registry to find it, it's going to have a fully qualified class name, which includes the package prefix, and that means it's got to sit above the folder with the package name in order to find the classes. So if you told me that the name of the class was, here's a main class, and you want to try and find it, and its name is net.rmi.utils.main. Well, to find that, you would have to start your RMI registry someplace like,
Parent folder of net.
Here's net, okay? And you say dir, and you say there's all this stuff. So you really want RMI registry to be here.
Yeah.
Registry. And now the RMI registry will be able to find classes in the .net package. Well, in the net.rmi.utils package, and all of the classes and all the packages. See, by starting it in the root of the compiler output, you basically give the default directory, which is the present directory, as the location for your class path search. So when you do the dynamic class loading, it searches down through the folders in order to get to the bytecodes.
Yes.
So having the RMI registry in the right class path is critical. You avoid this completely when you start the RMI registry within your Java program from IntelliJ, because then it inherits the class path of the IntelliJ compiler's output. Got that? So what does that mean to me? What it means is, if you go and you look at, for example, your project, right? Your project has a class path. So you mouse right on it, you look at your open module settings, and what do you see when you sit down and you look at your libraries? Right? You see the giant collection of jar files. These are all in your class path. So not only the output of the bytecodes, but every single library will be available to your RMI registry when you are using IntelliJ to launch it, because you're getting the class path that includes not only the bytecode output from the compiler, but the entire collection of all jar files that are in the IntelliJ class path.
How
Yes,
is it
sir.
auto-updating? So you said the big disadvantage of using RMI registry through your command line is it's not going to find the changes because it caches the first instance.
Yeah, that you have to restart the RMI registry every time your implementations change.
How did they? Is that what Java inside, for example, IntelliJ is doing for you now?
No, you still have to restart the RMI registry. So if
as a class, running the class.
Well, I'm not sure what that means.
So you initiate the RMI registry through your Java program.
Right.
And you run the Java program.
Well, you run a Java program which starts the RMI registry.
Yes.
Now let's assume you change the implementation. Now you must stop the RMI registry, which means you must stop the main thread of your Java program for the RMI registry to detect the changes. So somewhere in here it says net.rmi, and I think we had a hello world example. Was it perhaps under RMI synthesizer? I don't remember. Maybe this is it. I'm not sure. Oh no, this is just synthesizing. Where's the hello world example? Was that under chapter 43 of the book examples? I'm trying to go back to where we were last Yeah, this ain't it either. But you can see what's going to happen here. If you do lookup registry here on the local host for a given port, then that registry is going to have the class path of IntelliJ. Has to. Unless you can somehow find a way to override it. So what that does is it allows me to avoid having to start the RMI registry from that location in the class path. Moreover, if you did start it from within the terminal prompt of your Macintosh, you still wouldn't have the correct class path for IntelliJ, because you wouldn't have all the jar files in your path, unless you set the class path environment variable within your Mac. So if your Mac has a shell script that lets you set the class path, and unless that class path is set properly, and then passed as a parameter, which expands to a proper class path for the RMI registry, your RMI registry will not see that class path, because it ignores the class path variable. Right? So if I said, I may not even have my class path set. Class path, right? It's not even set. But if I said path, path has been set. So for me to sit down and set the class path now, in Windows, I would write a batch file. On a Mac, I would write a shell script. Right? I wouldn't write a batch file. It's the moral equivalent of a batch file, but a shell script might be written in C shell or T shell or Bourne shell or K shell. Right? It's a Unix system, so you get your pick of shells. You know what K shell stands for, right?
No.
Korn. K-O-R-N. David Korn. He used to work in my building at Bell Labs. He wrote his own shell. Yeah, K shell. He used to give rides to people. He had a big van. He was a very friendly guy. K shell. So here it is, right? Java is using, in Windows, a path for code base. Here in Unix, you get the path for a code base using forward slashes instead of backslashes. I mean, it's so, I don't know, Baroque or something, because it's the way they define the character for directory separators is operating system specific. So the directory character is always going to be something like forward slash or backslash. And in some cases on the Mac, I've even seen people use colons for directory separators, whereas under DOS, the colon is quite specific in its usage. So, now you've got your choices, right? 3 different possible character separators, depending upon what your operating system is.
So one could just develop the Java in their terminal or in their command line.
Absolutely.
Yeah.
There's no reason why you couldn't do the whole thing in Emacs or Notepad.
Or Nano, yeah.
Or Nano, or whatever you like, VI. And then I think they have VI on the Mac built in.
Yeah,
VI. Yeah, VI is the visual editor, which came from the old PDP-11s. Do you have that there?
Yeah.
You have VI. Yeah, just type Shift colon Z, and I think it'll quit. VI is
It's Shift colon Q.
Shift colon Q. Okay. I think I found the code, and this is the Hello World implementation. Here's the Goodbye World implementation. Right? somewhere in here we have an RMI version that tests these things, right? I forgot what we called it.
I think everything was in simple example.
Simple example, that sounds right. Thank you. So here's the server. Now when I start the server, does that start the registry first? Starting server, binding remote invocations, waiting for invocation. Okay. Now if I go to the client, it seems to take its time. Yeah, it says hello world. So now if you go back to this RMI hello server, what do you see? He gets a new remote hello implementation when he starts the server. So what that says to me is if I change the remote hello implementation and turn it into hello CR320 and then recompile, it's not sufficient. I also have to restart the, even if I do restart the client, I still have to restart the server to get it to reload and rebind to the RMI registry. So if I restart the client now, I wouldn't expect to see changes. It still says hello world. So for it to say hello CR320, I not only have to restart the client after the implementation changes, I have to pick up that implementation and bind it to the new context that you obtain from the Java virtual machine that is hosted by the RMI registry. So now I've got to go back to the client and rerun. Painful though that may be. And now it says hello CR320. So this illustrates the reason why you have to have a restart on your RMI registry. It's the only way to pick up the changes in the external implementations. So if you don't see changes in the external implementations, that's why. What do you guys think of that?
Yeah, this command line stuff.
Command line? Want to do it with the command line?
Yeah.
I'll do it with the command line. It doesn't bother me.
I think I understand it more rather than magic happening.
Here, I'll do it with the command line. First thing we'll do is we'll prototype the command line by getting the server and its fully qualified path name. So what I'll do is I'll take the fully qualified path name of the server, which will be in the comments. So it's called the net.rmi.simpleexample. Okay? Paste. Then what we'll do is we'll get the fully qualified class name for the client. Okay? And the client is called net.rmi.simpleexample. This example seems less than simple. .rmi hello client. Okay? So now what I'll do is I'll take the RMI hello client, okay, and I'll put it next to the RMI hello server, paste, so I can have them next to one another for convenience. just for my own personal convenience. And what I would like to do is I would like to start the RMI hello server and then start the RMI hello client. And I'll do that by running a Java virtual machine at the correct attach point. So here I am in the production output of my compiler. And now what I'll do is I will type start space mouse right paste. And now what you see here with start is the ability to start a separate Windows process inside of my computer. What's wrong with this? What's missing? Why won't this work?
If you have two windows, two shells.
You gotta run the Java virtual machine here, because the hello world, the RMI hello server, is a class file, and you need to have a proper virtual machine started. Yes.
I was wondering what the start command is because it's not used in on my command line.
No, it wouldn't be. You would need an ampersand to do this in Unix. All this does is launch a background process ID inside of a multitasking operating system. So if you want to do it in on the Mac, what you would say is Java space, and then in the background, to launch it, you would put in an ampersand. So space ampersand, after you type in java net.rmi.simpleexample.java hello server, in Unix launches a new process with a default priority inside of your operating system. It will not work here. On the other hand, what will work here is an invocation to Java net RMI simple hello world client. Copy and paste. At least I thought it should work here. Connection refused. Am I running a firewall here? Is that it? Port in use exception. That's not good. It looks like the server is not running. Let's run the server again. No, it says the server is running, oddly enough. Huh. That wasn't good. So if I run the RMI server, but then it runs the client, it's not happy with that when I do it from the command line. Don't ask me why, because I don't know. That should have worked. He's saying that port... Oh, I'm still getting port in use exception. It's like there's something running in the background somewhere. It's this. This is running. I had to stop that first. Life in the big city. So here's what you could do. Start 2 command prompts. Then change directories to the correct local directory for the output of your Java program, which must be here, right? And then do the same thing in the other command prompt. So now they're both at the same location. So what I'll do, I don't know if this will make a difference, but we'll try it. Right? Both in the same location. So we'll run the server in the on the top with the command java net rmi simple example hello server. Copy. There we go. Paste. Enter. So now he's waiting for invocations and he's starting the server. Good deal. Now let's go and try and run this client again. Let's see if he gives me a hard time. Copy. And paste. Huh, and it worked. Good deal. Now let's see how the server reacted. He said, I am running. Ooh, how cool. So, yes, you can do it through the command line. Happy day.
How do you change your Java code if you want to do it? Does that change at all?
I didn't change the Java code at all. All I did was change how I ran the Java code. Because Brian here said, I want to get away from the magic of IntelliJ. And I think at this point the magic has somehow faded. At least it has for me. It no longer seems magical at all. In fact, it seems really pedestrian. Right? We got two registries. We got a registry that's running in the same exact class path as the production code output, and the client is running in the same path. So you're going to ask another question now, aren't you? Good. I look forward to those questions. Keep them coming. That's all right.
Okay. So, if I'm using the command line to compile my Java code and run it, right? Where's the purpose of setting up the class path? Because I noticed that it just auto-generated the binary file, the class file, in the same directory that the Java file is.
Yeah, I'm of the impression that you want to change your class path if you want to separate the output of the compiler from libraries that you'd like to load.
Okay, that's what I thought.
You know, so in principle, there might be something that you'd like to have in your class path. I'll give you an example. Here's the path lion J for P out production J for P, where all of the bytecodes go, and there's a bunch of directories which represent package names that contain classes. But if you go into the superdirectory, you'll find there are other things here called jars. And if you go into the jars files, what do you see? A bunch of stuff. Now that's also in the jar. Right? These jars are clearly separated from the source. The jars are clearly separated from the output of the compiler. Now the compiler needs to manage its bytecode output in a way that makes sense, because it has to be able to detect when source code files change and when new class files have to be regenerated. But the jar files, which hopefully change in a relative seldom way, can also be in your path. And each one of those jar files actually represents a whole directory tree of other files that can be searched by the dynamic class path loader. Right? Because if you're looking for something like DOM, the directory object model for XML processing, then you would like to have the DOM jar files available. And they're going to have a whole big ecosystem of classes in them, right? So I'll give you an example, right? Here's a great example. Somebody said, gee, I like Dropbox, and I'd love to be able to use Dropbox from within my Java program. So if you make a directory called foo, and you copy the Dropbox API into foo, and remember, Dropbox is a proprietary product. It has nothing to do with Sun or Oracle in it, right? But you want to use it because Dropbox, right? Dropbox is cool. Everybody likes Dropbox. So you could say make the same claim about the Google APIs. So to gain access to these things, you need to learn the new APIs, and what you'll find is Dropbox has supplied you with stuff for authentication and file transfer. Basic, oh, did I make a mistake? jar minus xvf dropbox.jar. There we go. So now you see, aha, there's a whole pile of classes in here, and there's an API, and if you wanted to be a Dropbox programmer to develop your own apps for the cloud, then you would need to become somehow versed in the Dropbox API. Moreover, your Java virtual machine who's looking for a com.dropbox.client2.session.abstract session is going to have to find it somewhere. How will it find it? Well, it's going to search its class path, find the dropbox.jar, find the bytecodes associated with that class name, and then load them into its memory. So it has to resolve everything in its namespace into bytecodes, and that's how it does it. So every class path has a unique namespace, and you can have multiple, every class loader has its own namespace, and you can have a unique class loader, multiple class loaders within a virtual machine.
How can I turn a directory of class files into a jar?
Well, for that, let's assume that you have something called com, which is a directory tree consisting of a series of bytecodes, which is, in fact, is what we have. To generate a jar, you use jar minus cvf for create verbose using the following file. Give it the file name. Let's call it the brian.jar file, so everyone knows it's your library. And then pass it the root of the folder which contains all of the bytecodes. Then you can see they all get added. And now when you type in dir, you can see it's a nice big file, brian.jar. And now you can distribute brian.jar to all of your friends along with the Brian doc, or whatever we want to call it, Java doc for the Brian API. And presumably people will love it so much they'll donate to your PayPal account so you can go out and buy pizza or something, or bitcoins, or whatever it is you do with all of your ill-begotten booty. Right? I mean, this is how they all, you'll make a pilgrimage to Mount Gox and cash in. Although I think they're bankrupt now. Although I heard they found $250 million.
Oh, yeah.
This is the thing with digital money. You can, in the physical world, $250 million takes space, and it's kind of hard to lose it. But in the digital world, it's like, oh, look, $250 million. I found it. Where did I find it? Oh, it's on my flash drive, right? It's like, wow. It doesn't take up much space. It hardly takes any weight. And it's like, oh, wow, I knew I put that $250 million somewhere, right? And some people, actually, this is kind of interesting. It's digital money. You can buy physical coins. They're bitcoins. They mint them. They got little white light holograms on them, and they're hard to counterfeit, apparently. But people like physical coins for their bitcoins, which is an interesting... Sorry, I got off topic. But actually, I started a Bitcoin mining operation in my office. It's true. I had these GPUs, the Tesla cards. You've probably seen them, right? No? You've never seen them? Yeah, I keep them. Here's one. I always keep one handy for show and tell. This is 950 this is like a gigabit card right in here. It's got heat pipes coming out the top, and you can put as many of these in a single CPU as you can handle. They're 2-bus PCIe is the name of they call it PCI Express. They're 2 PCI Express card slots wide, and each one wants 300 watts or something. But you really want to start with a power supply unit with 750 watts for one. And then when you put in like 3 of these things, what you've succeeded in doing is removing the need to turn on the heat in the winter. You know, what people do is they run their Bitcoin miners with like 20,000 CPUs in places like Greenland, because that way they can use the natural Arctic cold to avoid having to purchase air conditioning, and they can also use the geothermal electricity, which is cheaper. So the big $250,000 or higher centers for doing Bitcoin mining are in places that are cold, because they throw off so much heat. I'll pass this around so you can see. So if you want, you can create your own Bitcoin mining system. But the key point is that electricity around here costs so much that it doesn't pay to mine against those people who are mining in scale in large regional data centers. But it sounds like, it's a fun...
Did you make off of that?
Nothing. I made
Why?
nothing. I couldn't compete with those guys who were mining with it.
You didn't make any money?
Nothing. Not a thing. I tried.
Why?
I wanted to make... I thought I was making coinage, but somehow it never appeared in my digital wallet. I felt really ripped off or something. It's a good networking...
Do you know...
this is really relevant because it's like networking, and it's digital money it's almost like a catalyst. It changes the way we think about
One
it.
of my friends does this.
Who does this?
One of my friends.
Oh,
He mines.
he does data mining.
And
Does he
he,
make money?
$20 a week.
Well, that's
What?
more than I make. I think I did it wrong. Now that you tell me your friend was making money and he wasn't using anything heroic like I was, like real
He said
cheap.
79, 79.
I don't either. Okay. So what I thought was interesting about the Bitcoin mining is that if you wanted to, you could get all the computers here in this room mining for Bitcoins at the same time, and donating into your wallet. You could make it a screensaver and deploy it widely, and then maybe pay people a commission for running your program for you. So then you have an opportunity to distribute the computing, right? You could make an RMI Bitcoin system that really works with a cluster, a computing cluster.
So, if we logged in all these computers and we had our server running in RMI, and then we set up these all as clients,
Yeah.
and then we just kind of like hid it so no one knew that we were using.
You could do it whenever the computers are idle. It's a screensaver. Screensaver computing is the moral equivalent of CPU scavenging.
I don't know that term.
It means that whenever the computer's idle,
Yeah.
it wakes up and volunteers its CPU resources for the cluster.
Have you ever heard of something called folding at home?
Yeah, sure.
Yeah.
That's the BOINC system. The BOINC system came out of Berkeley, and it uses screensaver type computing. I had 2 thesis students work in this area. Pavel, who's still around, he works at Pepsi, and Francisco, who moved down to Florida. But their code still resides here, and what I would do is I'd like to remove this directory, the foo directory, and so what I'm going to do, because I don't want to just sort of leave that directory there, is go into jars. Yeah, you can see the heat pipes coming out of it. Heat pipes, in case you're wondering, oh, he won't let me do it? Really? Is it because of my attach point? Yes. There you go. Yeah, I was mucking about in the wrong spot, and I don't like leaving that junk there. Heat pipes have a solid in them that turns liquid and then conducts heat away from the CPU toward the radiator and where the fan is at. So they efficiently allow for liquid cooling in your graphics card, or in your CPU if you like. Heat is such a critical problem in modern semiconductors. All right, so now that we've had our little lesson on what I would call RMI, are people still kind of unhappy with it? You're still having troubles?
Yeah.
Would you recommend doing it through terminal or command prompt?
I find it very nice to use the IntelliJ system, but when you saw me use it just now, I think it looked easier if you use IntelliJ than if you tried to do it through the terminal. But I'll leave it to you. I mean, what do you guys think? The simple RMI example just made it so much easier. When the server started, it ran its own little RMI registry.
What do you mean by using IntelliJ? Like, why is it using IntelliJ?
Well, it's using the class path that IntelliJ gives it. So when you launch the RMI registry, you're launching it with the same class path as that IntelliJ has, which means you have access to all the libraries.
So is that just where exactly? Is that just the registry utils? Is that what that is? Like where it's getting at? Where is
Yeah, RMI registry utils, get registry,
Okay.
will always start
It gives
the
it
registry from within the IntelliJ operating environment. So that means you will have the same class path that IntelliJ has. Right? Because check it out. When you expand this, and then you scroll to the right, look what it did. It gives you IntelliJ Launcher, and then it says what is it using? He says launcher path, right? Launcher path equals. And now what is he using for a path? This whole big honkin' thing, right? And then he says class path. And now here's what he's using for the class path. And look, he's got the jars. He's got everything going all the way. All these jars are in the class path. Now, if you want to do this, and you want to do it upright, what you want to do is you want to grab this output that IntelliJ generated. You want to start some kind of editor. Okay. You really want to use the class path, you're going to have to do it upright, right? So you'll have to set the class path. So you'll create on a Mac it'll be classpath.so. On Windows it'll be classpath.bat for batch file, and use the editor of your choice. Then you're going to have to arrange all of the files in your class path, and you're going to have to do something like this. Set class path to be, and then you're going to have this whole thing that follows. You could arrange it nicely so that you have one thing per line. You could make it like this. And then you could say set class, whoa, that's fun. Set class path to be percent class path percent, and then use a semicolon and follow it with the next directory you want to append to the class path. So then for me, the way I would do that is I would create a macro that would start a new line every time I saw a semicolon. Do that 100 times. Do it 100 more times. And now, to create the proper class path, and this is a pain. I mean, you really want to do this, right? Then you would have to do quote, paste, quote for each line. And that's how you would make it so that it looks nice. So then in theory, what you would do, I mean, this is sort of wacky, kooky stuff, but I mean, if you really want to do it, this is DOS. And we could do the same thing on a Mac. Great fun. So the way you do it is you create another macro, you quote it, go to the end line, and then repeat. And I guess you have to do it a bunch of times. And then, what does that buy you? A giant, humongous class path, which you can then set programmatically. Now, the question of whether or not I did this properly is open. Let's save it, and I'll just make sure it went into classpath.bat. I have zero confidence that I did this right, but if I type in set class path, it looks like it's been set. Now what if I type in classpath.bat, enter. Now if I type in set class path, set, how does one set the class path? Is it with a space or an equal sign? Set class path, it's with an equal sign, so I got it wrong. Emacs classpath.bat. Since it's with an equal sign, that means I have to put an equal sign in after each space, search for class path space, go back once, put in an equal sign, remove the space, and then repeat. Does that work? Yes, it does. Do it again. Now do escape 9999XE. And now we hit save and close, and I don't know, classpath.batch. Really. Set class path. Yeah, and now it's a big honkin' class path. So that's how you organize your class path. You can do the same thing with your regular path if you like. In a shell, under Unix, C shell would use a space instead of an equal sign. And I don't think they would use any of that backslash stuff or any of that C colon stuff, because then you're dealing with, Unix, and Unix has a whole different directory delimiting character. So yes, you can do it with the command line. And yes, there may be good reasons to want to do it with the command line. But if you don't have all those jar files in your class path, you'll be unhappy when you try to start to use those libraries from within your RMI program. You'll get a bunch of class not found exceptions at runtime. And I'm telling you, don't do it this way, because it's hard.
I was going to say...
But I have done it this way in the past.
Isn't there a way just to say, hey, everything under JDK 1.7.025?
Nuh-uh.
No?
No, that's not how the class path works. Class path is, it will only work recursively for single directory structures, not for individual or not for collections of jars. You can't use a wildcard for the class path when you're wanting to. You can't just say lib.\*. Wouldn't that be nice if you could? But that's not how class paths work. You need individual jars.
Even if they're all in the library?
You want to do it that way.
Folder?
The way you do it is you expand all the jars into a single directory, collect all the jars, and then make one jar.
Okay. That's bad.
It's a lot of work. And then it gives you no ability to maintain. Because if somebody says, well, I want to update my DOM library to the latest thing, you have to go in, surgically rebuild the whole jar file. And then, if you sign the jar files for deployment using Java Web Start, you've got to re-sign every jar file. I wrote an article on this called I Resign. And it basically means you resign everything.
Oh. Resign.
Yeah. I resign. And so, yeah, re-signing is very critical because certificates go obsolete every year. And that means you have to re-sign, or else your deployments will not work. Fun, right? Wasn't that fun? Yes, very fun. So I have an RMI synthesizer which allows us to gather multiple instances of Java code and generate the RMI output. You all now have had experience using RMI. We can now use our RMI for, we can use it for good. We can use it for evil. No. What I was thinking is that it would be really nice to be able to make a control GUI for a whole bunch of computers on a cluster. And I wondered what that would look like. And so I came up with this idea here. And what this does is it lets you turn individual computers on or off, and it gives you a little CPU light. The CPU light is this little rectangle in the upper left corner. And then in the lower right, we give you a relative CPU load. And so from within this control panel, I see perhaps 28 CPUs. And the CPUs can be identified by their IP address, their name, and perhaps the rate at which they're running. At the time I did this, Apple had just departed from CISC processors, known as the 68000. They were using the 68020s in the Mac 2s and the 68030s in the Mac 2 CIs. Sun was doing Sun 2s. Apple decided to use RISC, PowerPC. And the PowerPC 601 was a common processor, and it ran at 100 megahertz. Nowadays we have little ARM processors that cost $3 and go on the back of tiny little Spark I/O packages, and I think they're the size of a pinky nail. Here's one. It's the Spark processor and the Spark core, and it's an ARM processor. This is a little 32-bit processor that runs about $3 on the inside of the Spark I/O core, and you can see these things. Pass them around. So I thought it would be fun if we had a cluster here in the class. Running a benchmark would be required for us to get a sense of what the load is that the processor could sustain. The other thing that I had thought would be fun is if we could run like a little game. I had a tic-tac-toe program, and I also ran a program called Pong, which allows you to play Pong. I've got a Maze War program. My thinking on this is that it would be fun for us to be able to play games against one another using the network. Doesn't that sound like fun? Very fun?
Yeah.
Yeah? So the first question I have for you is how would we get to see what's going on the other person's console if we reproduce what they see and just transmit strong variables across the net? We might be able to efficiently run the game. The other way might be to take a screenshot of what's on the other person's computer and pass that back to us. So in other words, we basically get a remote control capability. So what do I need in order to do something like move the mouse around and pass that mouse move information across the network? I think I just need an X and Y location, right? That's sufficient, right? Any decent draw program can do that. How would I remotely control your mouse?
There's gotta be an API, right?
Yeah, I think the Robot API will do that. There's an AWT called Robot that'll give you remote control of the mouse. So I'm thinking about this out loud because I'd like to get your feedback on what we can use for our next generation final in this class. Because I very much would like to see us do something fun, like a game. So what do you guys think? What would be a fun game? I was thinking about something like Pong, maybe, or a nice real-time game. I've seen people do Battleship.
There's a game where you have a rectangle and you auto-generate one of those pixels, and two people have controls over some random figure like a square inside this big rectangle, and they chase to get to the randomly generated like star or whatever it is. And also the borders are, if I go up through the rectangle, I'll come up under it, and same thing left, come out. There are no borders, they are wrapping around. And so constantly there's being generated new like stars, and the little block characters are chasing after the star to get it first, and then you get points.
How about this? All I want to do is be able to play Pong against someone else.
Okay, that looks fun.
I liked your game, but I kind of found it a little bit difficult to understand. Now, if you think about it, what do I need to transmit in order to get in order to play? Let's assume you can see the screen, and you want to play Pong against me, and I'm just going to display this for everybody to see on the overhead projector. So I don't have to actually transmit a picture. So then what would you need in order to play me in a game of Pong? You have to control this panel, right? The paddle. The paddle has 1 degree of freedom, and that's the Y coordinate. So all I have to do is get the mouse event, right? And you can get that when you listen to a mouse motion listener. It'll pass back the X and Y locations, and the only thing you have to transmit back to me, I win, is the Y coordinate. And that'll control my paddle over in here. So what would we need to send? Just like an int, right? I have to keep calling, maybe you have to keep calling something like set Y. Right?
But yeah, they'll take the XY coordinate from the mouse pointer.
Yeah. And if you call set Y, maybe what I can do is something like this. You know, here's my little Pong. You guys have this. It's in your graphics.pong package. So in your graphics Pong package, you have an applet, right? And the applet implements the mouse motion listener, and it adds itself as a mouse motion listener. So what that means to me, you know, I don't know if you've seen this or not. A mouse motion listener, let's take a look, implements mouse dragged and mouse moved. So every time your mouse moves, a mouse event is generated. Right? So what you could do is find the mouse moved event and print the mouse moved method and print the event that is passed in. And what you should see is every time the mouse is moved, look, it gets the y coordinate, that's all you needed. And he gets e dot y minus 25, perhaps there's some offset or something or other. So if I were to, I don't know, I'll refactor this and introduce a variable in here just to make it a little bit more convenient for me. So I'll extract a variable, and what shall we call it? I don't know. How about we call it y? Enter. Oh no, that's already been used. Oh no, it's good. Y. So what I'll do is I'll print y, and we'll just see what y looks like. Y, apparently y will change, right? Because people are moving. Obviously something changed, maybe only x changed, but we'll print y anyway. You know, if you change the position of your mouse, it will generate a mouse moved event. But maybe the mouse only moved along the x-axis, in which case y hasn't changed. But I don't care, I'm going to print it anyway. So let's go and we'll print y, and what we'll do is we'll print out quote y equals end quote, so we know it's y, and that's going to slow down my performance quite a bit. But I don't care right now. I just want to sort of see what happens.
Sorry, quick question. In Java, when you have an event listener, do you have to end it?
You don't end it. It runs forever.
You can't end it?
Yeah. You see right now, it's waiting for not a mouse moved event, although here you can see it's actually printing out on the bottom very quickly. But it won't start the game until I click the mouse. That causes the ball to launch. And now it's coming toward me. And now I have to play. Right? So here's my x coordinates. What I need to do is I need to somehow control the other paddle. Well, at this point, you're talking about making a substantial change to the business logic. So what I would do in a case like that is I would keep the original code and make a copy of it, because what I'm about to do to this code is hacking, right? In a good way. Right? So I'd like to change the code, but I want to keep the old code. And one of the things that I want to point out for you again is that it's in graphics.pong. Right? So I'm going into the graphics.pong directory, and I'm finding this thing called Pong. I'm going to make a copy of it, copy, paste, and going to give it a new name. And let's call it Pong RMI, or RMI Pong. Yeah, that's a good one. RMI Pong. So this is my new sort of prototype for doing the RMI version of Pong. And I remember that there's this thing here called mouse moved, right? What was it? Mouse dragged, mouse moved, and here it is. And this is where I was printing out my mouse. But there's another thing going on, right? The computer, right? The computer is moving a paddle. And somewhere in here, the paddle is moving, and I'd love to know what happens to make the paddle move. Because in order for me to understand how to give remote control of the paddle for two humans to play one another, I have to examine paddle movement. So somewhere in here, there's got to be a little bit of business logic for painting the paddle. And I got to think, well, here's the racket point. Here's the enemy point. And here's the ball point. It's all stored in this thing called PS. Now, PS looks like some kind of data structure to me. And it's called the observable Pong state, PS. So let's look at this observable Pong state, and now all of a sudden we see something that could actually be moved with relative ease across the net. This could be serializable. It's called the observable Pong state, and it's in the Pong package. So the observable Pong state has a point called the ball point, a point called the racket point, the enemy point, and the ball speed. So he needs to have what I would call a geometry service. The geometry service needs to keep track of the location of the ball and the location of the two state variables of interest, the rackets, the enemy racket and the regular racket. Now, my question for you: which racket do you suppose is the computer? Well, let's check it. We don't know, right? Somebody will set the racket point. Is this just keeping score, or is this the actual location? I think it's a location. So let's print it out. S out, Control J, Enter, point. So this is called the racket point. Let's label it racket point equals, end quote, plus point. Sometimes I think reading code is much harder than writing code. But in a case like this, with a working program that plays a nice game of Pong, I don't mind trying to do a little analysis in order to figure out how it works. Keep in mind, this is not my code. This is code I snarfed off the web, just like you might do. So trying to figure out how somebody else's code works is an important survival skill, especially if it helps speed development a little bit. Now you could say, but Professor Lyon, I want the joy of doing it all myself, because like Brian, I take the hard way. And I could say, fine, you can do that, but I'm not gonna. I want the easy way. Now this may not turn out to be the easy way, but at least we can give it a shot. I'm running the wrong program here. I should be running RMI Pong instead of the observable point. So let's run RMI Pong. We'll print out the racket point. Looks like racket point started. Let's see if it changes. It does not. Now let's play Pong. Racket point hasn't changed. Let's see what happens if he scores a point. Oh, I would like to score a point. Somehow this racket point has not been updated. So if it's not being updated, I don't think it's for me. Doesn't look like anyone's setting it. So there must be something else here going on. There's a thread that runs. Here's the start on it. The thread is called this, and I implement runnable, which means I've got a run method somewhere, and here it is. He says check racket, check enemy, check wall, move ball. I'll bet you dollars to ding-dongs if you comment out move ball, it won't move. I'm hoping that's true. If I don't understand this code well enough to turn off move ball, then we're really in trouble. So let's see. I click and the ball will not move. Good, good, good. So that actually did something. Good thing. Checking the walls, that makes sense. What if we said check enemy, turn that off? I think move enemy must be the
Past that point.
yeah. See, I didn't check the ball. I think move enemy is what's doing it. So let's see. If I don't move the enemy, I'm saying that's the computer. So when you move your mouse on your system, you'll have to invoke my move enemy method.
Yeah.
So the enemy's not moving. Aha! We've turned the enemy off. Good deal. So in theory, if I want to, I could move the enemy myself, but instead of doing it by getting the enemy point, I could say ps dot get racket point dot y plus 25, and now I can control the enemy's paddle with my own paddle. Oh, yeah, look at this. Go, go, go! Ah, go! Well, I'm not very good with controlling the paddle. Apparently, I don't know how to play this game very well. It's not an absolute change. It's making relative motion. So I really need to understand what move enemy is doing. What is the rate at which this is moving? Oh my, there's code in here that looks fairly dense. Oh, he's looking at ball speed. Move enemy. Move ball. Get ball point. What if I just set it to get ball point dot y? You may have to do a little hacking here to get this to work, but that's fair. I'll just cheat a little bit and have the enemy always track the ball. It'll make it much harder to beat, I should think. Oh, he seems to be, I guess you know what this shows? It shows I don't understand how to move the racket around. That's very important. So what is, yeah, go ahead.
I'm looking at your observable Pong distinct class, and I'm feeling that you could, instead of moving the enemy, treating it like a set racket point, which is set by your movements on your mouse.
That's a good idea.
The only difference is in your set racket point, you're just saying this dot racket point, where all you have to say is this dot enemy point, which is defined as a point in your observable Pong.
Well, what he did was he tried to minimize the distance between the enemy position and the ball point y coordinate.
Yeah, we don't need all that fancy stuff.
Yeah, I wondered if I could make a copy of this and make my own version called Move Enemy 2. And then when I go back to my run method, I call Move Enemy 2. And now I can go in and modify Move Enemy 2 and see what it is I need and what it is I don't need, but keep Move Enemy 1 around. So I like your idea. Let's just rerun this program so that it invokes Move Enemy 2, and then let's think about this while it's compiling. What is it we should be doing here to make this track the ball a little bit more precisely? Because it seems like it's got a lot of lag to it. When the ball is going a little bit faster, I mean, he's not a bad tracker here. But he missed it. Why did he miss it?
Are you trying to improve on his algorithm?
Yeah, why is he missing? If the ball speed is less than 0, how can the ball speed be less than 0? Oh no, ball speed dot x is less than 0. Yeah, I gotta say, I don't understand. Maybe it's because he's moving down instead of moving up. So he's using ball speed to adjust his position. And now he says if ball point y minus 3 is greater than enemy position, then let's just reformat this a little bit and see if we can understand his... He's dividing by tough hit. What's tough hit? 8. Yeah, well, right. No, nothing quite like hard coding that thing. There is a compelling argument against having to use somebody else's code, because that means you have to understand it. I would say distance divided by tough hit can be refactored and extracted into a variable called replace two occurrences fudge factor. So I don't know what this... He's saying plus, if it's negative, then go plus fudge factor. If it's positive, go positive fudge factor. What if we change fudge factor to 0? And rerun the program. Do I need this fudge factor? What is that about? Because, I mean, you're the one who said you probably don't need all this cruft. And I'm thinking that's right.
I have a feeling it's going to play perfectly.
I don't know.
Oh.
He's not moving at all. Wow.
But he's so good.
But he's so good. So fudge factor was really important.
Yeah.
Maybe it should have just been set to the distance instead of distance divided by tough hit. This is testing our understanding of the code. I really don't understand this code. Oh, look how quick he was to respond. I think now... Yeah, look at that. He just went right to the proper location instantly. There was no lag at all.
The difficulty level right now.
Yeah, he tried to make it a tough hit. So I think he will never lose. But that's all right, because I do want it to respond instantly to the inputs that it gets from another opponent. Because I won't be playing the computer at the end of the day. I'll be playing one of you. Don't you think?
Yeah, but that like business logic is still getting the ball speed.
Yeah, does he really need ball speed?
Alright.
If he's just going to set the location...
I think just that right there, ps.get enemy point.y.
This stuff?
Isn't that just what we want? That's at the core, just what we need.
Couldn't you set it identical to moving yourself and then just have it like get the position of whoever's on the other end instead of you?
Yeah, I suggested something like that, but we could take move enemy 2.
What if we took this whole thing out?
Because wouldn't the logic of the enemy be identical to the logic of yourself? Just the values that it's getting are from a different machine.
Yeah.
Yeah, but my question on all of this is, how can I just set the paddle position? Maybe we need to see, like here we see move enemy, right? And here it says move enemy. Why is this moving the enemy? There must be something that's repainting the enemy, right? So when he does paint, there's got to be something that uses the enemy. So I'm saying the enemy is being created by this fill rectangle. And if you comment it out, you will no longer see the enemy. These two strings must be scores. The clip rectangle in here must be some outside, right? So that's what's drawing the enemy right there.
Yep. Now you're just playing a visible enemy. That never loses.
So if what you wanted to do was a fill rectangle where the enemy goes...
You see how it's calling ps.get enemy point, and up there you're setting ps.get enemy point to something? Excuse me, ps.get enemy point.y.
Well, I would like to suggest that the enemy point could be the same thing as your racket's point. in the y direction, but not in the x. And in this way, it would identically track my racket. So now I can set the racket location, or at least when I draw, I'll be setting the racket location. And it's identically. But you see, if I play, what will happen? It's not actually setting the data structure, is it? Oh, maybe it is.
Well, try and miss for the opponent.
Oh, you want to miss?
No, for him.
Yeah, oh, you want him to miss? Okay.
No.
See, he's doing something in his logic which is not being reflected in the graphics. So if you want it to be reflected in the graphics, what you want to do is you want to say ps.set enemy point to be now you need the x and y location for your rectangle, because you're overriding his own business logic. And you're going to use your present racket point. Paste. And what else does he need? He's getting cranky because his argument's different. What should it have been? I don't know what he's looking for. New point? What does this want? He wants a point, so I have to call new point. New point. Oh, I need a space. Point of x, y. Okay. So what I'm doing is, not only am I drawing a rectangle where I want it, but I'm going to set the business logic's point to be where I want it. I don't think making new instances of points all the time is such a great idea. I should probably just set the x and y location of a given point that's global, but let's make a new point anyway, even though it may be 6 times slower, because maybe it'll work, and it'll be fast enough. And there it is. Right. So now let's try and miss. And ta-da! I win. Now we can play again. And oh, so much fun playing Pong. So what did we do in the networks class today? Oh, maybe I should miss one now. Okay.
No, miss again.
Oh, you want the computer to miss, or the opponent?
Maybe he actually missed.
No.
Right.
Okay. So now you want me to miss?
No, you're fine.
Oh, okay.
You should probably delete everything.
And the scores are correct too, right?
Yeah.
So far, what did we learn in class today? That we can hack somebody else's code and do what we want with it. Right? Very important. So now, at the end of the day, what I'd like to do is I'd like to have a global point that can be set and used for drawing. So what I'll do is I'll create a little point. Let's see now. Public. Do I want a public point? I know what I'll do. Let's make a private point. I guess capital P point. O-I-N-T point. And we'll give it the name. We'll call it, how about enemy location? Enemy location. And we'll set it equal to new point of 0, 0, n/sen. Okay? So then what we'll do is we'll take this enemy location dot set location, and then what we'll do is we'll pass in the argument to new point. That way we're not making new points all the time. Now, when I do the fill rectangle, I can use enemy location paste dot x and enemy location dot y.
Wasn't that your position?
Oh, did I make a mistake? Yeah, that's my position. So I got to do set enemy point to be enemy location. And now I have to set the enemy location. I got it messed up.
You just undid it, right?
I just undid it, and I don't know how to redo it.
Command Shift, Control Shift
Control Shift C?
Z.
Z. Okay. So now I've got to go and get the enemy location and paste into enemy point. Does that sound right? Control Shift Z. That was a good one. Thanks.
That's just undo.
Great.
Should miss.
I should miss? Okay. I win a point.
Just checking.
Now,
So can you get rid of all the move stuff now? Like all the move methods for the enemy? They're relevant, aren't they?
that's a very good question. So what we'll do is we'll go to the run method and we'll get rid of this. How's that? And let's see if that allows us to continue play. Yep. Now what we'll do is we'll make it so that he loses and I win. Good deal. So
Can you
to
remove those from the code?
yeah,
Just
to your
clean them
point,
up?
this move enemy 2 can be removed, and so can the move enemy.
What about check enemy?
Let's just remove all of this. And as far as check enemy is concerned, I think we can comment that out and everything should run fine. We've just made this a whole bunch cheaper because all we have to do is play ourselves by using the mouse. Alright? So check enemy no longer matters, right? I can still win, and the enemy can still win.
Do you have to make sure that you can hit it with the enemy? I think that might do that.
Well, let's do this one step at a time. So we're going to remove check enemy.
What I'm saying?
Yes, sir. What was your question?
I think check enemy verify the collision.
Yeah, that's what I was gonna say. You should check the collision before you remove it. Like when you actually
Oh.
hit it, that it doesn't go through.
All right. Let's play another game and make sure check enemy. Let's see. I'm playing. Oh, no. We need it. So you need check enemy. That way it doesn't pass through the racket. You know, I got a basic question here. You know, there's this thread, and I think it has a sleep method, right? And when he calls sleep, he sleeps for 35 milliseconds. What would happen if he made it 350 milliseconds? Would that slow down the ball considerably? I'm thinking it would.
So lower the number.
Lower the number to improve speed. Increase the number to... Oh. Baby. So what would happen if you went the other way? It probably becomes impossible to play, right? 3 milliseconds per increment.
So you can make 3 different settings for each speed.
Whoa. Okay. Whoa. Aha. This is definitely challenging. Okay, yeah, we don't want that. Okay, put that 5 back in there. Right? It's in there for a reason. We know what it does now. That's all very good. I've got a little to-do in here. Ooh. Use RMI to move the enemy. So what's all this going to do for you? Now that you've got the RMI of, Hello World under your belts, we're now in the middle of this idea that we've got this plain old Java object, a lovely little game for playing Pong. And I need to use RMI to try and move the enemy. And how do we move the enemy now? We have to call set something or other, right? Enemy location. Set enemy point. So set enemy point now has to be something that we can do through RMI. Well, what if we did something like this? What if we said public void set enemy point, and we put in a point P, and what that does is it calls ps.setEnemyLocation. So then if I want to, I can call setEnemyPoint locally. And that kind of does the same thing that we were doing before, right? And so then the question of exactly how you would get the location from some remote place, I don't know, but this could easily throw a remote exception and then could be remotely invoked. So when that happens, we would expect this paddle to move. I win. Oops. So if the RMI Pong is supposed to be made so that it can be run remotely, what do we need to do?
Send a mouse event.
A mouse event or a point?
Just a point.
Just a point.
Locally get the mouse point with a mouse listener and just send the point.
Yeah. So what's going to happen on the client? Will they be seeing Pong play? And if they do, and Pong is playing, will they be calling set enemy point via RMI on the server? Which one will be the client and which one will be the server?
This is the server.
This is the server? Okay, so what does the client look like?
Just getting the mouse event and sending the point to the server.
So how will the client get a mouse event? Will the client have its own graphic user interface?
No, just
It should be able to see the same thing as you.
whatever you're using here to find the mouse position, we're going to put in a client class, I would imagine. Get it locally, and then send just the position, and have this.
All right, so let's assume that you want to write a program to get the mouse. How do you do that?
We import whatever API you're using here. I don't know which one's best.
Well, so let's import the mouse event, the mouse motion listener. Let's import. Here are some things that we need to import. Okay. Mouse event, mouse listener, and mouse motion listener. Now you've got all of these things sitting in a class. So now, how are you going to get the mouse to send events?
I have it update.
I mean, how do you program the mouse is my question. Do you guys have any insight into this? Where do mouse events come from?
The mouse.
How does who handles mouse events? Where in the Java ecosystem will you find the mouse events being created?
Yeah, it's a Java culture.
No idea?
On runtime.
Now, the Java virtual machine does not create mouse events by itself. There's a class, an API that you rely upon that must intercept and get focus on things like keyboard events and mouse events. So typically what happens with the keyboard or the mouse is the component gets focus. And when that component gets focus, when you click on the component or when you drag your mouse across the component, that's what is going to get the focus on your mouse events. So this is a critical juncture in. I now see the error in having you do this. You're missing in your background chapter 20 and chapter 19, which is really about events. See, if you don't know about events, you're going to find this code exceedingly difficult to understand. And so what that means to me is there's a bit of deficit in your backgrounds. And what I will say to you is you're going to need to learn about event listeners, and you're going to need to learn about how to create components, display those components, and listen to mouse events. So this is a critical juncture. Some components, like remember we talked about the runnable command pattern. Some components implement different listeners than runnable. Like for example, the mouse motion listener, the mouse listener. These things are listening for mouse events. So what I would suggest that we do is review chapters 19 and 20, because I think that what's going to happen here. Does anybody have a book with them?
I have it on my machine.
You're going to have to look at how listeners work. You're going to have to refresh yourself on how mouse motions work and how mouse events can be decoded. Let's see if we can get something useful for an example to get us started. So what I have is I've arranged my examples by package. In the book examples, you can see chapter 23 has mouse input. Here's a mouse motion listener. Mouse motion listener requires that you implement mouse dragged and mouse moved. When the mouse is dragged in my mouse motion listener, it prints out the mouse event. When the mouse is moved, it prints out the mouse event. I have a class that implements the mouse listener. Mouse listener is different from mouse motion listener. Mouse listener gives you different rate of events. Mouse motion listener, whenever the mouse is moved at all, you're going to get an event instance. Mouse listener is different because clicking happens a lot less frequently than, let's say, mouse motion. So if you click left or click right, or if you use the mouse wheel, or when the mouse is pressed and held, or when the mouse is released, these are relatively infrequent events. It's much more efficient to listen to them. So now here is a component called a closable frame, which is going to be displayed just as a frame on your screen. And then what I would like to do is create a mouse listener and a mouse motion listener. Now I've got to link the mouse listener and mouse motion listener, and I'm even putting in a wheel listener in here, and I have to add these listeners to the frame so that when the frame gets focus and you start to click on the frame, the mouse events flow into the frame, and then you can get printing on the console. So if the frame isn't listening to the mouse events, nothing will happen. So this is the critical linkage right in here. When you do add mouse wheel listener, add mouse motion listener, add mouse listener, adding those three listeners to the frame gives the frame the ability to receive those mouse events. Then when you set visible to true, the frame should actually be seen. At this point, when I run, I should create a closable frame of 400 by 400 pixels in length, and it should listen to mouse events. And you can see mouse moved, absolute positions. Now I'm going to click, and it causes this little rectangle to follow my mouse. I didn't have it. You want to make it so that it can move when you drag. Then, yes, sir.
Is there a cf.remove mouse listener? That you could
Probably. Cf dot remove mouse listener, mouse motion listener. So if I remove the mouse motion listener, mouse motion listener, then when I move the mouse, it will no longer receive those messages, in theory.
I wonder if you could use that then to create like a delay.
So it still sees the mouse listener, but it does not see the mouse motion listener. Now, if you wanted, you could use the mouse motion listener to here's mouse pressed. When the mouse is clicked, he sets the location of the device, or whatever that thing is, the rectangle. If you did mouse new mouse listener, mouse moved, you could say this dot add mouse motion listener, this dot add mouse motion listener, new mouse motion listener. And now when the mouse is dragged or moved, you could say dragged. I think that's good, because then if you click and hold, it'll be dragged. Then paste, change the point. So now when I go in and drag the mouse around, it should change the location. Yep, there it is. So that's working. Now as the mouse is dragged, the rectangle, I'm holding down the mouse button, is tracking the mouse. When I release, the rectangle stays where it is. If I click, the rectangle tracks to the mouse. So now we've got a way to take mouse motion and alter the rectangle. Now the question is, how would you transmit that y coordinate of your mouse while it's dragged. If you don't want it dragged, you could move it from dragged to just moved. Because you're using, when you're doing Pong, it's not dragged, it's moved. Right? Whenever you move the mouse, it moves the paddle. And that's actually working. And it's tracking. What do you think of that? Now, if you look at this, and where you see where it says New Mouse Motion Listener, you know that's an interface. But I provided an implementation for the interface by creating a local anonymous inner class. The local anonymous inner class has a limited scope, so you can't make reference to it by name. But you can convert an anonymous inner class into a named inner class. Do you know how to do that?
Embedded classes.
You could make a nested reference data type out of it by doing a refactoring, and you could convert anonymous to inner. And then you can give it the track, well, you better use an uppercase character, track mouse class motion. How about track mouse motion? Track mouse motion, that's a good name. So now the track mouse motion class updates the location every time the mouse is moved. Got that? Now suppose you said I don't want a nested reference data type, but you would rather have a top-level class. How would you do that? Right? In other words, this class is contained inside of the MouseMe class, but maybe you don't want this class contained inside the MouseMe class. So to turn this from a named local inner class, right? We had an anonymous inner class which was local. Now we have a named inner class which is local. How do I make a top-level class out of it?
An interface?
It's a nested reference data type that I would like to unnest. I don't need an interface for this. I need a refactoring. So what I could do is I could move, I think F6 will do it, pass the outer class instance as a parameter, make the parameter name myClosableFrame because it has to set the point inside of that, and just say refactor. And now you have a non-nested reference data type. Now suppose you want to take this non-nested reference data type and you want to make it a public class instead of a private class so that it can reside in its own Java file. How would you do that? Just make it public. But that's an error, right? Because public classes should be contained in their own Java file. So what you'll have to do is move it to the mouse input package, chapter 23. Now he's giving me a problem because it's inaccessible from the constructor. I've got an issue, right? What's the issue? Probably the constructor is not public, so he's going to give me a hard time with that. So I'll leave it with default visibility for now. Or maybe I have to make it private. That's all right. He's still giving me a hard time. What's up with that?
That doesn't mean there's an error.
Really?
Yeah. Wait, where is it? It would be red, wouldn't it?
It is red.
Where?
Right
Oh,
there.
I guess I can't see it. Oh. Oh.
What's his problem? He's okay now. I made a mistake during the refactoring. He didn't like the conversion. Not sure why. I can get back to that later. I'll bite that bug later when it bites me back. So I've got this idea that you guys need a chapter 23 read.
23 or 19 and 20?
I think you're going to need to go. Do you guys have a book? Nobody has a book? What's chapter 19? I forget now.
Introducing events.
Events. And 20 is?
Design pattern and events.
And events. And then 21 is?
Viewing HTML in Swing.
That we can skip. And 23 is?
Mouse input.
Mouse input. Well, you definitely need 23. I assumed you guys had some event programming in your background. Was that a bad assumption?
Yeah. Like a little bit, like nothing.
Yeah?
For me, anyways.
I don't think it's too complicated.
Well, I would say this then. Read chapter 23, and if you're overwhelmed, you'll have to go back to chapter 20 and look at it again. You don't have to read it in detail, but you should be able to read about mouse events and learn about these mouse events, because when the final comes around and you want to use the mouse to build an RMI-based game, you're going to be hurting units if you've never looked at the mouse chapter. So I'm thinking you better read the mouse chapter. Does that sound fair?
Yep.
Now, I got a question. If I do not assign a homework, will you still read the mouse chapter?
Yeah.
Yep? Promise? I'm not going to assign a homework then. The homework is read and understand the mouse chapter. If you do not understand the mouse chapter, go back to chapter 20 and look at the events. You may have to read some background if you never got through the mouse. I'll tell you something. The mouse is your most important PIC device on any computer that you're going to encounter. The trackpad on your Mac is the same identical thing from a computer point of view as the mouse. No difference. It's a PIC device. Back in the days of yore, we didn't use the mouse. We used a light pen. And the light pen, you could draw it straight on the screen, and it would read the electron beam as it went across and gave you an XY coordinate. And I used to write CAD programs in Fortran using the light pen. They don't do that anymore. Have you guys ever seen a light pen? It's educational. Here. This is the original PIC device. Light pen. This is before the mouse. Light pen wiki. Yep, there it is. So the pen had a tail, and you could draw straight on the screen with the pen. And yeah, back in the days of yore, pen computing. Yeah, this is the original pen computer. Right? So check it out. I mean, that's in 1969. So this would be used. You could use it for graphics. You could build a paint program. A lot of times people had vector graphics, so you could draw vectors and drag them across the screen using what they call rubber banding. So you grab an end of a vector and you drag it, and the vector would get longer and longer, and then you release it, and the vector would stick. The original vector graphics thesis was written by Ivan Sutherland, and he used a program for his thesis called Sketchpad, where you had an intelligent CAD program. You could put down like 3 points, and then it would draw a circle that would go through all 3 points. You draw two line segments, and it would draw a circle that would be tangent to the 2 line segments. In other words, it had an idea about how to deal with geometry. And that was considered a breakthrough back in the old days. Back when I was your age, we'd write programs in Fortran and program our vector graphics computers with our light pens. And we didn't have no stinking mouse. And we didn't have no stinking trackpads. back in those days. I used to use a computer called the IMLAC. IMLAC Wiki. I think they still have pictures of these things somewheres. They used light pens too. Do they have any pictures? They don't have a picture. There's no pictures. Well, that's stupid. Why don't they have any IMLAC pictures? It's like they've been lost to history or something. That's weird, man. Why wouldn't they have a picture of the IMLAC? It didn't look like that. Oh well. Lost to history. I'm really bummed. Old computer. The IMLAC Museum. There it is. It kind of looks like a computer, but this part is just the terminal. And at the other end there would be sort of like this big controller in the machine room. So you guys have a reading assignment. I'd like you guys to be able to write a game for your final. So being able to track the mouse sounds kind of important to me. Transmitting mouse data across the network, that sounds real important. This program that we've got here, you should look at, and it's in Chapter 23 on mouse input. And I dare say it might be possible to start with a real simple program like this and get RMI to work just by transmitting X and Y locations across the network. Right? In fact, we could even modify our Hello World programs to transmit and print X and Y locations. So that doesn't sound like it would be too terribly difficult, right? Because you're really just making kind of an RMI invocation on set point. And then what you're passing through is an X and Y location. I think points might be serializable, but I'm not sure about that. I'd have to check. Even if they weren't, you could certainly set X and set Y. Right? If you just call set X, set Y remotely, that'll be sufficient. You won't have to pass the instance of a point across the network. Probably be better that way too, right? Because if you think about it, set X, set Y is just passing two 32-bit quantities, because the ints are 32 bits. So that's kind of efficient. You're not making new instances of a point class and then passing it across a network. Instead, what you're doing is you're just taking these kind of raw groups of bytes and passing those across the net. It's actually more efficient even than a string that says hello world. It's less data. So you got your reading assignment. You know where we're going with this. Couple things you want to do. Look at the Chapter 23. Look at the MouseMe code, and look at this Pong program a little bit. Make a copy. Play around with it. I think you'll have fun. I think this is going to be a good final. I'm looking forward to seeing you guys all play Pong against one another. I think this is going to be great. Have a good evening. That's all I have for you for today.